So let me repeat what I was trying to say. I was trying to say that if you see this phasor diagram, here E can be obtained as a sum of V plus IDXD plus IQXQ. But we cannot find it because we do not know this angle delta. So we have to find some other method of finding this. So what we have found out from this derivation is that if we add V plus IAXQ, we can land up in this point C, and then we know this angle delta. So what I was saying is that we can write this voltage as E and this voltage as E dash. E dash is some voltage which is not E but is in the same direction as E. E dash is this voltage. The magnitude of E dash and E are different but they are in same angle. So in a serial pole synchronous machine, if we have to find the voltage terminal voltage E, induced EMF E for a given terminal voltage and current, what we will do, so what are the things that will be given? V terminal voltage will be given, I will be given, IA, then XD, XQ will be given, and power factor cos phi or phi will be given. These are the things that will be given. So what we will do, we will first find E dash. How we will find E dash? E dash is from O to C. What is E dash? E dash equal to V, I am writing this as vector, this plus V at an angle, we will take this as reference, V at an angle 0 plus IA XQ. So all these are as a vector. So we can write it as V at an angle 0 plus IA at an angle phi, where phi will be given to us, into XQ at an angle of 90 degree. So if we evaluate this, we will find E dash at an angle delta. So we have found out this. Now how to find E? E will be equal to E dash plus CE, that is this plus CE. So how to find CE? CE we have already found out, it is, we are talking about magnitude here, magnitude of E plus magnitude of ID into XD minus XQ. We will find magnitude only. This will be magnitude of E, and angle we have already found out here. So it will be a two-stage process of finding this E dash, terminal voltage E. It will not, we cannot directly find the value of E dash. There is another way of directly finding E dash, but that will be quite cumbersome. We will not do that. We will follow this method of solving this. Now let's again repeat what I have said. What I have said is that the problem that we are discussing is to find induced EMF E in a salient pole machine. So what are the steps of doing this? The steps are simple, but we need to understand why we are doing this. So in the problem, what will be given? A terminal voltage Vt will be given, current Ia will be given, the reactance as XD will be given, the reactance XQ will be given, and the power factor will be given. The first step will be not to find E but to find E dash. This is our first step, to find E dash. What is E dash at an angle delta? That is equal to V of t at an angle 0 plus IA at an angle of phi into XQ at an angle of 90 degree. Once we evaluate this, we find the angle delta. Now with this how we can find magnitude of E? Magnitude of E will be magnitude of E dash plus magnitude of ID into XD minus XQ. Now how will you find this ID? For finding this ID, you need, if you see here, what is ID? ID is IA sin psi. So ID will be equal to IA sin psi. So how you can find psi? The power factor phi is given here. Delta you have calculated here. So now you can find psi. It is not always that psi will be delta equal delta plus phi. For example, if it would have been a leading current, the current will be somewhere here. In that case, psi will be equal to delta minus theta. So you have to draw the phasor diagram and understand whether psi will be delta plus theta, delta plus phi, or delta minus phi. So you have to draw the phasor diagram and understand, and accordingly we will find out psi. Once you find psi, Ia is given. So Ia sin phi will be ID. If you substitute IT here, XD and XQ are given. So then you can find the magnitude of E. So what is the final result? The magnitude of E, we will have it from here, and angle of E, we will get it from here. So this is our E that we want to find. We will do a numerical in the next class, and then the things will be much more clear. Thank you.